talk about hypothesis testing. Now, there are a lot of different tests we can do with hypothesis testing. We can do z-tests, t-tests. We can do hypothesis testing dealing with proportions. We can also do chi-squared testing. There might be more, but that's what I got off the top of my head. So you have to be able to distinguish between the differences. What are they talking about, and how does that fit within one of these four? So let's look at an example. Our friend Buddy claims the mean salary is $45,000. We sample 20 people and get a mean of $48.3 thousand with a standard deviation of 8.5. We're going to test his claim at alpha is 0.01. All right, now, this seems really, it's got a lot of words. Well, let's figure out what we're talking about. So, first of all, what is our claim? Well, Buddy claims that the mean is 45,000. So, that is our null hypothesis, or our HO. Now, that means that our alternative hypothesis, in this case, is the mean is not 45. Right? So there's our alternative hypothesis. What else we know is we know that our sample mean is 48.3. Our sample standard deviation is 8.5. We know that because we sampled 20 people and we were given that we have an alpha as 0.01. So the red is what we're going to use to test this. Now, I'm a big fan of using rejection regions and critical values. If you like p-values, that's fine. I am going to do rejection regions for this problem. If you would like to see an example using p-values, let me know and I'll come up with a new one. But for right now, we have to decide first what hypothesis test are we going to do. So we are going to use a t-test. Why are we using a t-test? Well, n is 20. Right? If we have a small sample, we need to use a t-test. So the first thing we need to do is find our rejection regions. So when we're looking at this, we're trying to figure out, okay, here's my rejection regions I just colored in. What are the values, my critical values, positive, negative? I know it's two-tailed because our alternative hypothesis is the not equal to. So that gives me a two-tailed. Well, how do we figure out what our critical values are? Well, you're going to need to use your textbook and the chart at the back of the book, where we know that it's two-tailed. So because it is two-tailed, we are going to use a t alpha divided by 2 because it's two-tailed. So 0.01 divided by 2 is 0.005. So this is the value we're using. I think that's across the top. And we're going to need to know our degree of freedom. So remember that the degree of freedom is n minus 1. So 20 minus 1 is 19. So on your vertical column, you're going to go down to 19. You're going to go across to 0.005, and you are going to see a critical value of 2.861. So that means when we look at our chart here, critical value. So we are at 2.861 and negative 2.861. So when we find our test statistic, if it falls within one of these regions, then we will be able to reject the null hypothesis. In this case, reject the claim. So that's what we're looking for, whether or not we are going to fall in our rejection regions. So now we need to find our test statistic. So formula. Our test statistic is x bar minus our mean standard deviation of the square root of n. So let's look at all this stuff, right? This right here is our original or our claim. So let's plug in our numbers. Our sample mean 48.3. Our original mean is 45. Divide that by our standard deviation over the square root of our sample size. So 3.3 over 1.9, and I end up with a test statistic of 1.736. So when I go back to my chart here, my test statistic falls in here at 1.736. What does that mean? That means we do not reject the null hypothesis. Do not reject. We cannot reject the claim that the mean is 45. There is not enough or not sufficient evidence to reject the mean being 45. We have to fall in the rejection region to have the evidence to show that it is. So in this case, we don't reject it. You really can't say anything. And that is a t-test for hypothesis testing.